Welcome to STARS Launch Pod, where we chat with innovators who are overcoming challenges, pushing boundaries, and collaborating to make space more accessible and sustainable for humanity, one launch at a time.
It's one small step for man.
Here's your host, Susan Wise.
Welcome to STARS Launch Pod, Space Technology and Research Sciences, brought to you by starsciences.org, where we connect, collaborate, and accelerate. I'm your host, Susan Wise, and thrilled to have with us today John Mather, Senior Astrophysicist at NASA Goddard Space Flight Center, cosmologist and Nobel Prize in Physics, and served as Senior Project Scientist for the James Webb Telescope. John Mather, welcome to our show. Welcome to Launch Pod.
Thank you. I'm glad to be here with you all.
It's truly an honor. I'm actually a little nervous. I don't mind saying, because I did watch Cosmic Dawn the other day, and what a great documentary to learn so much about what all went into the Webb telescope. And it's kind of, around the news these days because there's a lot of cool things going on up there that we're watching. And what are you currently working on to help further the space industry right now?
My current idea is called a hybrid observatory for Earth-like exoplanets. So the idea is we've got big telescopes being built here on the ground, and if we could block the starlight that's coming in, we would be able to see the little planets hovering nearby. So that's the idea. Been thinking about it for a long time, and we're making some progress. So everybody seems to think we need to have a space telescope to do this. I think the answer is no, not really. You could use a telescope on the ground, and at least we are planning on having 3 giant telescopes. 2 are U.S.-led, and 1 is being built in Chile right now by a European-led team. So they're huge. They're way bigger than what we can hope to get into space anytime soon. So if we could possibly harness the power of those great telescopes, we would be able to get a picture of another Earth in a minute. I don't mean the continents and oceans. I mean a little dot, but hovering nearby its star. And so we could do that.
Is this still in the dream stage, or has this project really actually gotten off the ground? Well,
we are in the dream stage in the sense that we don't yet really have a drawing that says build it like this.
Mm-hmm.
What it requires is pretty amazing. It's called a star shade. So you need something that looks like a giant pointy sunflower, 100 meters in diameter. So that's huge. That's as big as the length of a football field.
Okay.
So huge. And we need it to be ultralight because we have to push it around with rocket engines while we've got it in space so we can get it lined up. So we want to put it between the star and the telescope and hover on that line for a while so we can take a picture. So if we can do that, then we do what I say, we can get a picture of another solar system in a minute.
Wow, that'd be amazing. So I guess, the sunshade would go up in pieces and you would build that part in space while the other part is on the ground? By getting that right?
The telescope's already being built on the ground that could do this. And yes, we would unfold our star shade in space. We're still thinking about how to do that, and there are a lot of different ways you could do it. We're working on an inflatable design where you have a whole lot of plastic and cables all folded up into a box. There's another way you could build from small little cubes assembled in space with little tiny robots. Or you could build something where it's all previously designed and unfolds itself out in space, just with typical mechanical structures with ribs and plastic, things like that. So a lot of different ways we could do this. We haven't settled yet on the best way.
This is very exciting because, we have the James Webb Telescope, but you're taking this another step further.
Well, that's our hope. Of course, our astronomer colleagues have been thinking what they really want and really would be wonderful is a telescope as big as the Webb, but especially designed for hunting for Earth-like planets. So it would be comparable in effort and difficulty and budget to Webb, but we could do that. And it's what the astronomers already said they want. So if we can do that, then we certainly hope for it. But this is an alternative and has the advantage that you don't have to build a telescope. You just have to build a star shade and put it in the right place. So I make it sound like it's just
simple.
That,
it's just so simple.
Well, honestly, we don't really know the details, but I'm pretty sure we could figure them out.
Well, it all starts with an idea, and you've had plenty of good ones. So, what has been one of your biggest aha moments?
Well, I think there are quite a few. The one that led to the Nobel Prize was while I was still in graduate school, it was pretty clear to many of us that if we could get a satellite project up, we could measure much better than we could do on the ground. We were wanting to, in those days, to look at the cosmic microwave background radiation, which is primordial heat that was here from the early moments of the universe. So it fills the entire sky, fills the entire universe. And if you could measure the color, which was where my thesis project was about, you could tell if it's really cosmic. And when we got our satellite up, the Cosmic Background Explorer satellite was launched 15 years after I got out of graduate school. And that was a pretty amazing aha moment, too. When we saw the data come in and we saw that the work had worked, the equipment was fine, it didn't take very long to say, yes, indeed, we got the prediction was true. This really is left over from the early universe. By the way, I'm not calling it the Big Bang because people think immediately of a firecracker or an explosion, which is the opposite of what astronomers see. At any rate, that was number one.
I wasn't
The
going to go
second-
there to the Big Bang, but since you did, I totally see me as Penny and you as Sheldon.
Oh, by the way, I lived in Berkeley in a graduate student house, which was, as we called it, the Big Bang Theory household.
Okay.
We realized that afterwards, and we tried to document it. But at any rate, coming back to that, we also knew right away that we needed to make a map of this cosmic background radiation to see if it's equally bright in all directions. And so we proposed that too. In 1974, when I got out of graduate school, I got a chance to do this. And I didn't think it would work. I think we're just youngsters. All of us team members were very young at the time, but it was good enough. It got people started. And yes, we went ahead and built it with, of course, a serious engineering team at NASA Goddard to lead it and make it happen. So, but it was truly a discovery to see that there were hot and cold spots, the pink and blue blobs that you've probably seen in the maps of the sky. Nobody knew they were there. By the time we launched it, people were pretty sure we had to find it. Anyway, nobody knew when we started that there was anything to see. So, two huge accomplishments that you could not be sure would ever happen.
And I'm sure you've had your challenges during these projects. Is there one that comes to mind that was a really big challenge, and would you like to share how you overcame that challenge?
Well, sure. Well, I guess all big challenges are team challenges.
Mm.
In the case of the Kobe satellite, the big challenge was the Challenger, which blew up shortly after launch, and we had been counting on using a space shuttle to launch the Kobe satellite. Oh, we're not going to do that. So we better redesign, go on an expendable rocket, it was called, a Delta rocket. And so, okay, step back, redesign. We were very fortunate that the instruments mostly did not have to be changed much, but the spacecraft had to be changed a lot. So fortunately, the team was able to find a rocket that we could go on and accomplish this huge engineering challenge to reorganize it, refigure it, and put it in a smaller box to send it up. And that worked. So that was huge. There were a few negative aha moments that I should mention.
Okay.
Once in a while, I came to realize, at least twice in the Kobe project, that people were counting on me for a particular calculation, and I had made a mistake.
Okay.
Oh, so, well, when you figure this out, you say, well, I made a mistake. We'll ever fix it. I'm going to call up my friends, can we fix it? Now, we did find a way to fix them. But the lesson I take from that is never trust the boss, especially if you are the boss.
Right.
If you don't have somebody checking your work, you can lead the whole team over the cliff. So do not do that. Make sure somebody's verifying your calculations. And if people like you and love working with you, that doesn't prove a thing. It doesn't mean you're right.
Mhm.
So
We're human.
that's
So
pretty important. We're all human, of course.
Yeah.
So that was a kind of aha moment about that project. Going on to my next big project was the James Webb Space Telescope.
Mm.
And when I got to that one, I didn't actually think of it. It wasn't my idea. I got a phone call one day, a few years after the Kobe satellite was launched, to say, well, we're going to start a project. Would you like to work on it? I said, oh, yes, this is the coolest thing since ever. This is the thing any young astronomer should want to work on, because this is the most powerful tool people had ever asked for. And we had a chance to do it. We had strong support from NASA headquarters. We got strong support from Congress. And so that was the other kind of strategy I have. I should talk about, how do you choose what to do? What's the strategy? Choose something to work on where other people already know that it's important, if you possibly can.
It's good advice.
So it means you're not there alone. It means you've got teams to work with. And it means when something goes wrong, you're with people who can solve those problems. So, of course, things do go wrong, especially on a really big project like that one.
Mhm.
And again, it's people who save you. It's not because we're smart. It's because the project is important to people, that these problems can get solved. So you probably know, it was pretty well known that the Webb Telescope team ran out of money at a certain point, and it was obvious we could never finish the job with the budget and plan we had. So, okay, you got to fix that. So how do you fix it? Well, first thing you do is you get a review committee, because Senator Mikulski asked us to get a review to say, are we doing the right thing? And so the committee said, actually, they did good work, but they didn't ask for enough money. So if you didn't ask for enough money, then you're never going to finish. So they got us more money and more time. And so after that, we were able to stick to the plan, even despite having COVID come up during the finishing stages of the mission. So
lesson is to ask for more money than you need.
Yeah, actually, this is an old lesson.
Okay.
James Webb, whom we named the telescope after James Webb, the man,
Yes.
who was the second administrator of NASA.
Mhm.
And he's the person who figured out how to get to the moon and made it happen. And the story behind that is he was on his way to see the president in a taxi cab, and he realized as he was going that the budget he was asking for wasn't enough. He doubled the budget in the taxi cab on the way to see the president. Yeah, that was enough. But if he had not done that, it would have been a complete disaster for the entire project.
Well,
The
that's
nation would have been embarrassed.
yeah.
And
If
so
you don't
he's-
ask, the answer is always no. So, ask for what you
Yeah.
want and then double it.
Yeah, well, it means that you're never smart enough to really know how much a project is going to be when you've never
True.
been there before.
That's true.
Anybody who ever does home repairs finds this out. So we should all be at least as smart as our plumbers are and ask for time and money when it takes things to do.
What's the most exciting thing that we're seeing right now with James Webb Telescope?
Oh, well, my goodness. We have found a few things that we didn't totally expect. We knew we'd be looking for them, but what really pleased me was we found a category of objects that had never been seen before, that seemed to be, well, we call them little red dots.
Okay.
They're happened very early in the universe, in the first more or less billion years, and none of them are left. So they came and went. So we haven't really figured out what they are. So they seem to be either extremely compact luminous galaxies or possibly galaxies with black holes in the middle. But we can't see the black hole. So this is tricky and interesting. So a clue in the big mystery of where do the black holes come from?
Mm-hmm.
And I guess, we seem to see a big black hole in the middle of every galaxy. Nobody knows how that really happened. The black hole start the galaxy, or did the galaxy make the black hole? I don't know yet, do we? The other coolest thing that we found out is that, of course, there are many planets around other stars, and we can begin to study them. So we can't study little ones like Earth very well. That's too hard. But the big ones, especially the ones that are close to their stars, we've gotten to study their atmospheres and their chemistry and how big they are and how massive they are and how hot they are, and see various interesting molecules in them. So we're not there yet to say there's another Earth 2.0, but we know there's an awful lot of candidates. So,
It wouldn't surprise me.
yeah, I think I would be shocked if there were no Earth 2.0.
Right.
On the other hand, nature is nature, and so we might possibly be in a very rare case.
Mm-hmm.
So
Well,
nobody's yet found another solar system out there that has the same kind of arrangement with 4 little planets, an asteroid belt, and the 4 big planets. None of them are like that. So maybe our situation is rare. On the other hand, you just got to go look and find out.
What would be a piece of advice you'd like to share with our listeners?
Well, I think number one, if you're working on something that's important to you and to the world, then you can find a way to do it. And number two, ask for help. If you don't ask for help, it's like you're not worthy of helping.
Mm.
So declare for yourself that your project and your idea is worthy of help, and people will help you. And you can avoid reinventing the wheel. It's already been done. So you don't have to waste your time doing things that other people can do for you well and quickly. So build a team. Life's a team sport. And so if you want to do your idea, then you have to build a team around that idea with people. So that's the story.
Good advice. Before we wrap up, do you have a passion project, either past or present, that you'd like to share?
Well, the one that I really love is this orbiting a star shade, because nobody else really took it seriously, but we did. And I really think it could work. So if it can, then it will be really exciting.
We might be able to
For
see the little
us.
red dots better and
We
the
might,
black hole.
might be able to, well, probably not for that purpose,
Okay.
but we have other versions that would help that question too.
Okay.
Yeah, it's called adaptive optics for big telescopes on the ground. We can do it better than we do today. And so using a satellite beacon to help, that's another kind of hybrid observatory. So we got lots of ideas that are all in this sort of general direction of helping big telescopes that we already have work much better with adding something in space.
I cannot wait till, we start seeing the first pictures and gaining more knowledge from the next telescopes.
Well, thank you, Susan. We have great hopes and many possibilities.
Thank you so much for joining us on LaunchPod. We really do appreciate you. John Mather, Senior Astrophysicist at NASA Goddard Space Flight Center, cosmologist, Nobel Prize in Physics, and served as Senior Project Scientist for the James Webb Telescope. Oh, my word. Thank you again for joining us today. Be sure to join us where we connect, collaborate, and accelerate. We'd like to invite you to join starsciences.org to receive a free one-year membership. Just enter the promo code FRIENDS321. If you enjoyed this episode, leave us a review and subscribe. And until next time, keep looking up. Thank you, John.
Don't miss an episode. Subscribe on your favorite streaming platform. Watch us on YouTube and follow us on social media. Stars Launch Pod, propelling us forward, one launch at a time.